Hey guys, this is the 18th meeting of the GDC. Thank you very much guys for getting this far because this is actually going to be the final section of section 2 of GDC class. Okay, so this means in the next meeting, which I'm going to go more on, the next meeting is going to be starting our next game project, which is going to be a first-person shooter game project, all right? I know that a lot of us love playing FPS games, so that's why I wanted to start making some games that maybe perhaps relate to us, at least the games that we love to play, like a Call of Duty. I'm being very stereotypical right now. I'm really sorry. You might be interested in other type of games, but a lot of us, even me personally, I love playing first-person shooter games. Okay. Obviously, as I said, there are many other titles out there, and we will start getting over that. Okay, they're like things like Clash of Clans. It's like they're its own type of category. There's a balloon shooter games, and kind of like Clash Royale kind of things as well, right? It's like tower defense type of games as well. We might go more on that as well. Like we will. There are also like car games, right? There's Forza, there's Need for Speed. There are many car games right now in the market, in the gaming market. But we would like to focus more on this first-person shooter games because aside from these third-person games, first-person perspective games are also very popular. So obviously our game is revolving around first-person shooter, but your game, after watching or starting the next section, you could apply these first-person shooter concepts into your own first-person perspective game. So it doesn't really have to be on first-person shooter. It can just as well be about like a game, but just based on first-person perspective. All right, but that's just more on like what I'm talking about for the next few weeks. Okay, that the next meeting will just be starting our new project. But that comes about when do we start, okay? I am going to cancel the GDC meeting for March 5th and March 12th. Although I've canceled today's meeting as well, I'll be uploading this meeting soon on Edpuzzle. And obviously, if you're seeing this on YouTube, I've also posted this on YouTube as well. All right, so that's one thing that I've done. So I'll be canceling the meeting for the next 2 weeks. That also means that I won't be recording these meetings as well because my schedule is really tight for the next 2 weeks. But because of that, I'm also giving you guys 2 weeks at least to work on your game jam project. Okay, so this time the instructions are on Discord. You can check them out later. But yes, you can win 50,000 Me6 XP, 100,000 GDC coins, and third thing is also getting Discord Nitro, 1 month free Discord Nitro. You cannot like work with a partner or a team this time. For the last project, I was being very flexible. This time, I do have a set of guidelines that you need to follow in order to be able to be part of this competition. Now, as I said, a lot of us are not interested in competition, but if you are interested in getting that GDC certification, you need to make sure that you have completed your game, okay? It doesn't matter if you want to be in the competition or not, but you must have submitted your game, and it should be complete and following those directions as well. So yeah, that's that on these competitions, and that's why I'm giving you these 2 weeks in the middle to be able to work on that project, because I do want you guys to work on this even more, because I'll be starting to post them on social media to show that there are people making games in the GDC. It's not just for that, but you guys are amazing, so you should be able to show your talents. So because of skipping these 2 different meetings, our next meeting, which is the first meeting for the 3rd section of GDC, will be on March 19th. Okay, so just keep that in mind. That's one of my announcements. So now let's actually talk about what we've learned in the last meeting. First meeting was the last few weeks. I've been most of the video for the last week was just on my updates, and it's kind of weird because that's usually not what I do. But it turned out that it just took out most of the time. But luckily, we were able to learn the new concepts that we were supposed to learn in last class. And one is like being able to refactor. It's just a review. Basically, I've been talking about refactor throughout this entire course. But as I said, our course is just like a DNA, right? Our course is like a DNA because like it's basically like we start from learning refactoring, and a DNA is like a strand. It goes like diagonally, but we come back to where it was here, right? So it's like one period, one oscillation. So we're back to that concept of what refactoring is. We just went a bit more in depth and tried to apply that idea of refactoring in our own code, in our own program. This can be like some sort of a practice for most of you guys, at least those who are trying to make their own games and trying to make their own games more simpler and better to understand, more visually able to read. And I said there were like downsides to that, right? The more simple your program is, the less complex it is. Now, less complex is both good and bad, right? Less complex is meaning it's good for us. It's easier to read, but at the same time, you cannot make your game super advanced, right? That's the downside. So you need to know where is the balance between that. It's usually in that balanced area, the 50-50 area. But it really suits for the person himself, whatever they prefer. And also the game. So another thing we talked about was also cheat/debug keys. A lot of us, when we are debugging our games, most of the time is taken on actually playing the game. Okay, and second, we get really, 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 really distracted from the game itself. So usually when we're trying to find bugs, we kind of get drawn towards the game and we just never get to the problem itself, that the one we're trying to fix. So that's why we created some cheat keys. So let's say we're playing a game and it had 50 levels and you're trying to look at the 43rd level, what's going on. So you could just create like a cheat key in the game somewhere. You can say that if key code, like if your input.keycode is like, K, if you press K on your keyboard, then you should automatically go to level 43 and you should see something happening there, at least what change you made. Another thing is like disabling collisions. So in our last class, we also taught about, how to disable collisions. We also used Boolean States if we weren't wrong, which was also one of our content, which I was trying to teach in this section of Unity. You could check that out in our GDC class content. It's available there on our YouTube channel. Okay, that was a lot on cheat/debug keys. We also talked a bit about how to design the environment. Now, I have already designed the environment. I will show you guys what I've done. But I didn't really do that in the last meeting. But I did try to teach you guys how to start, right? You could start from simple objects given by Unity, like cubes, circles. Try to pick some shape that relates the most to your game, right? It's based on intuition. You should know what it is automatically because you're the one who knows most about the game. If you know more about the game, you should get a rough idea of what shape you can kind of start off with, right? If it's a futuristic game, you should have some sort of geometric shape, which have a line which is more pointy rather than curvy. Now, if it's more of a cartoonish game, it's more for kids and that kind of stuff, it's usually more like curvy, unless it's a futuristic game. That's a whole new thing. You also need to choose the aesthetics you like. Some people like curved aesthetics. Some people like pointy aesthetics. I like pointy aesthetics because I like futuristic style. As you can see over there, the nanoleaf, that's pretty much aesthetic based on geometric shapes, which are really pointy. I like futuristic style. That's just my own preference. But that doesn't mean like you guys need to like futuristic. You need to make your game based on your own liking, based on your own personal preferences. But keep in mind that not everyone might like that. So you need to also keep in mind your audience's preferences as well. So that's on that. But then I also showed my what's the difference between local and global. So when you're rotating objects, you can rotate the object relative to the environment or relative to the object itself. If you're still confused about that, check out that previous video. It explains it really well. I also talked about how to manipulate your lighting, the Skybox itself. I didn't really mention about what Skybox was, but Skybox is just basically the environment itself, the sky. That's the Skybox. So usually in games, developers usually just put a plain image of a sky, like clouds usually. So you can see that on Roblox. You could see that on many other online games, multiplayer games. They just use a Skybox. It's just an image that they stretched out on the sky, and it's like a circle if you kind of think of it. It's revolved around a circle. So it's like a square image, and they stretched it on a circle. That's basically Skybox. There's more in the Skybox. We use Skybox so, we could also affect lighting based on our Skybox, based on the colors of the image you selected for the Skybox. I made my game a bit of a Mars look. So, because of that, it's a bit of an orangey kind of sky, which you'll see pretty much soon. But that's that. I also taught you about how to make your custom Skybox. And that really was it on the side of, the previous meeting. So now let's actually start on what we'll be doing today. Okay, so today we'll actually be learning about headers and tooltips, which is such a great tool, especially when you have a lot of serialized variables in your game. Remember, serialized field variables are like just those variables that you have to drag and drop into the inspector component, and the code will refer to whatever you referenced it from the inspector component and use it in the code accordingly. Now, obviously, it has to fit the data type you chose. So if you chose an audio source data type, well, you can only put an audio source inside of that. Okay, you cannot put you cannot put a light object inside of that reference thing. That's serialized field. So we're going to learn a bit more, because usually what happens is in the end of the code, when your game gets more complicated or you progress more into your game development journey, you're going to have crap ton of serialized variables. And sometimes they're almost the same thing. There's light 1, light 2. So sometimes you don't know which one to put where. So headers and toolbox will help you on that area. Another thing we'll be talking about is moving obstacles via code. Now, obviously, I taught you guys how to make spinners in the last game project. We did use code to move that obstacle, but now we're going to take one step ahead and make a thing known as oscillators. Now, if you don't know what oscillators are, they are in many 2D platformer games. They just move back and forth, like repetitively, they just move back and forth. They can move up and down, back and forth, basically where you like to go. So they just choose 2 points and it just moves within these 2 points forever. And we're going to learn a bit more about that. Because in the last section, we just talked a bit about like what spinners were. And we just used transform.rotate to just make it keep on spinning using the update method. So we will try to get ourselves like such as I said, the DNA method again. We're just going to come back to that topic about how to move obstacles via code and think one step ahead by making it an oscillator this time. Okay? And a hint, we're going to be using periods and sign and all that kind of stuff. So we'll get really, really math related into this. So if you're not getting math, that's all right, because it's kind of just either a refresher course for you or you'll try to learn something new. I'll do my best to simplify the work here today. Okay, and another thing is NAN bugs. Sometimes what happens is in your game, you're going to get some bugs. It's called NAN. We're going to learn a bit more about that, how to fix it. And then finally, we're going to talk about designing level moments. Okay, just give me a moment. I forgot to write something. Okay, and then we're going to also talk about some designing level moments. So some ways that which can also help you extend on like how to make your environments much better, how to make it relate to the rocket itself, how to make that game essentially successfully prove that intention to execution approach. The thing that you intended your game to be, has it executed the way you intended it to be, right? So we're going to use some game design approach to make that really happen. And then finally, we'll talk about quitting it, how to quit your application. As I said, I already talked about this. This is a review, but I want to make a video that clearly depicts this, like it shows this, so I can make a timestamp so that whenever you're searching on Google or you're trying to find a video of mine which has quitting an application, you can always refer to this one and just come back to it and know, oh, that's how you do it. And that's it, right? Because this, my YouTube channel, GDC YouTube channel, is mainly for, you know, hey, like, I don't know what to do this, so you can just search it up and boom, you got it with the timestamp. You should automatically find it. It's like a bit of it's a bit of a gaming library so that you could find some stuff that you don't know and just easily access it through this portal. All right, so let's begin. Before I do anything, I would like to tell you guys some updates that I did to my personal game. So let me just go to the main screen. Okay, and I'm going to go to Unity. So right now, you can see that I've done a lot to level 1. You can see that first, as you can see, is Skybox. If you wonder how I did that, you can check out the previous video, but I will show you what I did. I went in Materials, and I created a Skybox. And what I did is I just went to the lighting settings, and I just dragged the Skybox to this so that it made the change there. Now, keep in mind, the more levels you have, you need to apply this change to all of your levels. So that means when you move from level 1 to level 2, if you applied that Skybox change in level 1, it's very likely it hasn't been applied to level 2. So you have to do the same thing by going to rendering, lighting settings, and dragging that Skybox into that level as well. Otherwise, that change hasn't been made. Okay? So that's one thing. Another thing that I added was lightings. Okay, so if I go back to level... Well, the first thing... Before I talk about lightings, the first thing is the environment. So I use cubes. I just basically use cubes. I put them in this this empty game object and just make it a parent object, which consists of these child objects, which are just obstacles, really, individual obstacles. I just put them together and make a parent object, which is obstacles. And you can just see that once I stack around, I kind of give like this kind of Mars-ish kind of look. Now, obviously, it doesn't look exactly like Mars, but I kind of gave it that orange kind of look. Now, if you're wondering how I got this kind of lighting thing, well, you guessed it. I just said the word lighting, so that should kind of be like a trigger phrase for y'all. I made a lighting. I just added point lights around and just basically added colors to it, okay? So what I did sometimes was I just dragged the color of my Skybox and apply the change over there. But I don't think I will do that, so I'm just going to Control Z. But I just played with different colors. So my recommendation is if your environment, your Skybox color, is the color that you're choosing to be, what you can do is you could use this eyedropper tool over here and just click on that, and the change should be applied over there. Now, I don't want to do that because I already selected my colors, so you need to keep on play testing the perfect colors you like. Okay, so that's what I did around this thing. I just used the lighting and I just applied the lighting everywhere, and simply that's it. Okay, another thing was I went into the code, and so not into the code, but into the Rocket prefab, and I added two lights, point light and a spotlight. Now you might be asking, why can I not see these lights in, well, why can I not just see these lights over here, right? I've applied the light, I applied some sort of light into this prefab, I went into the prefab, and I added it from there. But why can I not see these lights? Well, it's because the way Unity designed it, you cannot see these lights when you go inside of the prefab. You can only see these lighting effects when you're outside the prefab. So what I recommend is whenever you add these lights, you add it from the outside, right? And then what you do is you go back to the prefab inside of this hierarchy panel, and then go over to overrides and apply all. So from there, it's going to apply that change to all of the other instances of the prefab in the levels, in other levels of your game. Okay, so that's my approach to this, because the benefit of that is once you apply it from the outside, not from the, when I say inside the prefab, is like going inside over here. When I say outside, it's like outside over here in this entire environment. Okay, the reason why I recommend adding your lights from the outside is because you can see these lights. Okay, so the benefit of that, one, is you can actually apply the change and notice that, okay, a change is being made, right? Whereas if you were gonna just guess it by just going into this, well, one, you don't know what change is happening with respect to the environment, and two, you just can't see the lights, so you can't see what's really up. So I think, if I'm not wrong, you might this white thing is the light itself. So when I say you cannot see the light, you can see the light. It's just that you can't see the change with respect to the environment. All right, and that's the reason why I recommend, making the change from the outside and then using the overrides to apply to all of the instances of the prefab and other levels of your game. Now, what did I really do with these two lights? Right? It's not like, hey, I started playing the game and boom, there's lights. No, I added two cool features. So if I play the game, you can see that first, there is no light over here. But if I press the Y button, a spotlight comes up, and you can see down here that I get a debug message that the spotlight is on. Now, if I press the Y button again, it's gonna, first, the spotlight's gone. And number two, it debug again to me in the console panel that the spotlight's off. Now, if I press the U button, you can see that the point light is activated. And if I press the U button again, the point light is not activated anymore. It's turned off. And that change and that debug messages are still coming up again, just like we've seen for the spotlight. Now, you might be asking me, how did I do that? Because I didn't really I didn't really mention this in this meeting. That's why this is an update. So what I did was I just created a script called Rocket Light. And what I did was, I actually didn't do this outside from the code for safety reasons. I did it inside the code, and I just added it into the parent object. This is the parent object right here. I just dragged this rocket light here, and you could see that over here as well. Okay, and then what I did was I went back to the code, and this is actually another thing I was talking, rocket light, and I first just ignore this header and tooltip. We'll get there. I added this thing called serialized field game object light 1. Okay, so I made two serialized variables. Okay, and they have a data type of a game object. So whatever I store in this light 1 from the outside, right? So whatever I put over here, that should be a type of a game object. So I cannot just put an audio file and assume that that's a game object. It can only store game objects here. So I can only put game object for both of these things. All right. So I made two of them. One is light 1 and one is light 2. And then what I did was then I created another another variable, and it's not serialized anymore. I just made it a data type of light, and I just called it spotlight, and I made another one called point light. And then I made another thing called Booleans. Okay, I made these two Boolean variables. One is point enabled and one is spot enabled. Now, these are like Boolean conditions. This is something that we talked about in the previous classes. I think it's like 2 classes ago. It's called Boolean States, right? So these two Boolean States, as kind of a refresh for our memory, it's just like, this is going to help us know whether the light is enabled or not through our code. So whenever the light is on, we could make this enabled equal to true, and we could make the point enabled equal to false when the light is off. And this is going to help us whenever you're pressing the Y button, it's not going to flicker. Okay, it's going to prevent that flickering. And number 2 is going to tell the code that you should only turn the light on if it's off. Otherwise, just keep it off, and it should and change the Boolean accordingly to what it is. But before we do that, we need to use the start component, not the start component, but the start method to reference these things. Okay, we need to reference in other words, we need to instantiate it. We need to instantiate these 2 light variables. Okay, it's called an object, but we're gonna have to reference these variables to something. So what we can do is we could take this light 1 and get the component of light from that game object. Because if you think about it, if you go to these 2 objects, point light and spotlight, it does have a component called light. And what we do is we just basically mess around with these lightings as well. Now, another approach that you could have done was you could have just added two components called lights. But again, I think that would cause an issue because you're getting both of these lights again inside of your code. So in order to prevent anything, in order to, prevent any problems in your program, in your Unity game, I just made 2 objects. And you can realize these 2 objects are game objects, which has a light component. Okay, and they have a different type of light component. This one has a point light component, and this one has a spotlight light component. Okay, and then we just drag that here, as I said, and where is it? It's over here, and we just reference the light component and just make that reference. We make the spotlight reference to this light component of the light 1 object, and we make the point light variable reference to the light component of the light 2 object. Okay, and then we initialize both of the spotlight and point light, the enabled thing. So when I say .enabled, let's go back here. It's just that button. So if I turn it off, it's off, and if I turn it on, it's active in the environment. So when we say .enable is false, we just check mark this. We remove this check mark. So if we remove this check mark, it's off. Okay, so initially for both of these lights, it's off. Okay, and then after that, we're gonna make another thing. We're gonna set these 2 Boolean values to false. We set it to false because they're not enabled, right? Point enable is just saying whether they're enabled or not. So this becomes true if it's enabled, and this becomes false if it's not enabled. In this case, right now, it's not enabled. So we set both of these. We've set both of these variables to false initially. Now we make an update method, and this update method will keep on calling this method called trigger light, which is a method that I made. Now, what does trigger light do? We go to this basically this entire big pile of code. Okay, so the first thing was that if I press the button Y, you could change it to anything you want. This is just an example that I've done. Then what I do is, again, if it's not spotlight enable, so this exclamation as a review is just not button. It's just saying not of anything. So spot enabled. So if it's not spot enabled, so in other words, if spot enabled is not true, then we run this code. So in other words, this must be false. Spot enabled variable must be false in order to run this code. All right. Now let's say it was false. Then what we do first is we make this true. We make the enabled thing set to true. So give a check mark on that. And then we set this variable spot enabled to true, and then we debug the message that the spotlight is on. Otherwise, if spot.enable is equal to true, then we turn off the thing. When I say turn off the thing, it's just like just remove the check mark and it turns it off. And then we set the spot enable to false, which is the state whether it's enabled or not. Now, since we remove the check mark from that enabled thing, we have to also say spot enabled equals false, because now we need to tell the code that the light is off. And then we give a message that the spotlight is off. Now, you might be asking me, won't it happen this way that, hey, if I press the Y button, it will turn true, but won't it automatically after that just make it false? Why is it that when I have to press the button again, this becomes false? Well, it's because this if-else statement is within an if statement. All right, so in order to do else statement, you must do this statement first. You must pass this condition. So what happens is if this becomes true, right, then we do this code and that's it. So in order to do this code again, we must again satisfy this condition, and then it will run this code again. All right, that's how it works. This is why it's not like, hey, once we press Y, it becomes true and then it becomes false. Well, because we have an if-else statement, and it's also that we have an if statement within an if statement. All right, that's the reason. Okay, and then we also did the same thing for you. It's the same thing, except instead of spotlight, we changed it to just point light. Okay, and it's the same idea. So if you still don't understand what I talk about, try to go back, wind back up from this video, and you will get the same idea of what I was trying to talk about over here. So we had, it's 25 minutes. That's pretty good. Yeah, and that's basically it as what I've done for as so far in the background for this project, other than making the slides for the GDC. So now let's actually start talking about the things that we're going to talk about today. All right. So first thing, headers and tooltips. It's something that I've kind of gave you kind of a foreshadow. So let's kind of talk about it. So headers and tooltips, what are they? Well, first of all, headers, it's just something made for serialized variables. Now, the first thing you need to know is headers and tooltips are both made for serialized variables and also just for variables in general. But usually it's actually made for serialized variables because you can see that on screen. So it's just kind of a title we give to a serialized variable. You can see that in our code, right? If you go back to our code over here, you might see from the beginning that, hey, Russell or RR, whatever you want to call me RR. Why is it that we called it light 1 and light 2? Why not spotlight and point light? Well, one, it's because we already made two variables called spotlight and point light. But then you might be asking me again, why don't you just make this spotlight object? Why can't we just call this spotlight object? We can't call it that. I said you can go for it. But the thing is, it's just a very long name and it's not cool. Okay, having a very long variable name, that causes problems in your code, especially when you don't have some sort of a automated bot that can complete some predicted completed statements for you. For me, I use tab 9, but some of us don't have that. Okay, so I would just simplify it to light 1 and light 2. But obviously, if you want to call it spotlight object, you could always go for it. Okay. But I would like to keep it as light 1 and light 2. But then, for me, that causes a concern, right? So then what I do is I create a header. So the real question is, what's the syntax behind header? Well, this is what we do. We put it in a bracket, right? A square bracket, like this. And then we type header with the capital H. In a parentheses, we just type in quotation marks what we're going to call it. Okay, and remember that we don't put a semicolon at the end. So keep that in mind. This is not a statement. This is just like kind of a... It's kind of like if you think of it in CS, if you took a CSS course, this is just like a design thing for us, okay? It's a bit of an aesthetic thing for Unity, and it's just an addition. Just think of it like an aesthetic. So let's go back to our code, and let's see what we did. So for this one, I type header, and then I wrote in the quotations, spotlight object, okay? Inside, and I put parentheses around it, but within the quotation marks, so this thing is entirely treated as a string. Okay, so let's see what happened in the Unity thing itself. So if you go to Rocket, you can see that there's something coming up here, spotlight object. And one, you should already know that this is kind of bolded out. This text over here, it's bolded compared to the name of the serialized variable itself. So for us, if we go back to the code, the variable name for ours was light 1, but that wasn't bolded. The header, which was spotlight object, was bolded. You can see that over here. So keep in mind that the header is bolded, and the variable name that's serialized that's right next to it, it's not bolded. And that's why I recommend using headers, because you can clearly see that, okay, this is the spotlight object, that's the point light object. But as again, I said that, if you already know if you already know this, you could also just change the name to something more meaningful. But some of us don't do that, okay? Some of us just don't do that. And that's why this is another approach into making your game more organized and a bit better to read and understand. Another thing that's not headers are tooltips, which are just like comments, okay? They're just like comments that we document on the serialized variables on the inspector component. So the way we write it is, again, the same thing, square brackets, but instead of header, we type tooltips. So the first T is capital, but the second T is not. So keep that in mind. And then in the parentheses, again, we just type our title here. So instead of title, we can just type your comment here. Again, we don't put a comment in the end. We don't put, sorry, not comment. We don't put a semicolon in the end. This is not a statement. This is a bit like an aesthetic for us. It just kind of helps us organize our code a bit. Not our code, but our variables a bit, especially in the Unity project, in the Unity editor, not in the Visual Studio code. Okay, so when I say comment, it's not like something you could see it, right? So if I go back to our code, our tooltip for the first light1 variable was this is referencing to the spotlight game object. That's within the quotation marks. But if you go back to the code into the main project Unity editor, you can't see this anywhere. Well, the thing is, if I hover over the variable, you can now see it. It's saying that this is referencing to the spotlight game object. So the reason why people prefer to use tooltips is when if something's just too long to read, right, and it's not a good idea to put it as a header, and you just want to hover over what it is, you can just quickly see that, oh, this is what it is. It's just trying to reference to the spotlight game object. So that's another way, another approach into organizing your game. So sometimes, putting a lot of headers can kind of pile up your inspector panel. So that's why a lot of people maybe just don't prefer to use headers. They prefer to use tooltips to just say, if you just hover over the variable, maybe even if I go over it, you have to hover over the variable name, not over this. You hover over the variable name. It's kind of an easy way to see that, oh, this is what it means. And if I just go away from it, it's gone. So it's kind of like it's kind of an effective way to have your stuff done so it doesn't pile up your entire inspector panel with different stuff, because you can see that the header panel does take up space. For right now it doesn't, but once you have 20 different serialized, I hope not. If there were let's say 20 serialized variables and you had these things right there, you could see that compared to you not putting this, putting that header takes up more space than it is. Right, so that's why some people use tooltips, and these are just some great things for you, some great tools for you specifically to see that, hey, sometimes if you don't know what this variable does, you can just go hover over this sometimes and say, oh, this is what it does, or maybe the header can explain the entire thing for you. All right, so these are just some cool things that game developers use to help simplify, or in other words, organize their code, so it can make you one step ahead into being a really, really good game developer. All right, so I don't know why it's not. All right, okay, fine. Now we're going to talk about moving obstacles via code, okay? The first thing we want to talk about is what we're going to do, okay? We're going to try to move our object. Like, let's say we're going to go back to our game. We're going to attempt to make one of these objects oscillate, okay? We're going to try to make one of these objects oscillate. We're going to try to make this specific object oscillate. I don't know what I touched. I hope it. Oh my god! I hope I. Yeah, it's nothing. I thought it was a bug. I thought there was a bug on my toes, but it's okay. All good. All good. I'm gonna try to make this specific obstacle oscillate. Okay, so when I talk about oscillation, it's trying to go up and it's trying to go down, and it's trying to go up and it's trying to go down. It's gonna keep on doing that repetitively, forever. Okay, it's not gonna have a time limit or anything. It's just a bit like an oscillator, right? If you see in a game, like maybe in a Mario game, you can see that there's some things just moving repetitively. And we call those things oscillators, okay? Or at least that's what I call them, and I recommend that you call them. And I'm just going to change the X rotation to 0. All right, and I'm just going to get the R tool out. Sorry, I'm just going to get the R tool out. And yeah, let's just try to make it look maybe a bit smaller, so you can at least make the player play the game, right? Yeah, so as I said, it's going to try to oscillate up and down for us. You could also oscillate left and right. You can also go nuts. You can also make it diagonal, whatever you want. But we're going to, for now, for simplicity, we're going to just oscillate up and down. The question is, how do we do that? So we need to try to picture out what we're trying to do. So to move in a consistent direction, we have some sort of starting position, right? And again, Unity 3D, the 3D version of Unity, has 3 coordinates. We call them vector 3. Vector 3 stores 3 coordinates, x, y, and z, right? And we're trying to store a starting position, the place where it starts initially. And then we have a movement vector, all right? And let's say hey, we have a starting position. It's moving to 10. So it's moving from 0 to 10. 10 units, Unity units, okay? So movement vector is usually considered to be the final position relative to its relative to its original position. Okay, so in other words, it's trying to move 10 Unity units on the x-axis. And now what we do is we have this movement factor. We can convert this movement thing into a movement factor, which is usually between 0 and 1. Okay, so what we usually consider our movement vector to be, which is technically our final position, that's our movement vector. Okay, and this movement factor is just the thing that we're going to multiply by this movement vector to get some sort of offset in the end. Okay, so movement vector is your final position. Our movement factor is just like the individual rates between we're going between 0 and 1. And we multiply that factor by the movement vector to get the real offset value. And we will be using offsets in our code. And an example here would be like, hey, we have a movement factor that's currently at 0.5. So what's the offset? Well, if it was at 0.5, and we were going to multiply that by 10, right? We're going to get half of 10, which is 5. So in other words, we're going to get where it currently is just by multiplying the movement factor by its final position. Okay, it's that easy. But before we do anything, well, first of all, let's try to actually implement this in our game. Okay, so let's not talk about signs yet. That was kind of a bit of a spoiler alert I gave you there. Spoiler. That's not good. So what we can first do is we can first make a script. We call it an oscillator. Okay, and we need to always make a new script when we're talking about a whole new idea. We cannot put any code regarding oscillation in a movement script. We cannot put a code for oscillation in a collision handler script or any other scripts, right? Or even the rocket light. So that's the way you have to think. If you're wondering that, hey, when do I know when to make a new script? You need to ask that question. Is it applicable to put, or does it make sense, in other words, to put it in the current scripts that you have? If it does not, then you have to make your own script. So for me, I made my code oscillator. Okay, so we first need to know what variables we need to store. Okay, what variables we need to store. So first of all, we need to think, hey, we need the starting position. All right, a lot of us may think that, hey, maybe it's a float value or it's an int value. Actually, no, it's a vector3 value. Okay, and vector3 value is just storing the x, y, z coordinates of the object that the component is on. Okay, so we can call this the start position, as my automated bot tells me in the code, and that's that. We got a variable for that. Now, what's another thing that we need? Well, we need a movement vector, right? At least the final position of where that object's gonna go. So we're gonna make a serialized field. Okay, serialized field. And we're going to call this, again, vector3. And this is actually going to show you a better picture of how vector3 really looks like. And we're going to call this move. Well, we're going to call it move vector. You can just call it move vector if you would like. And finally, another thing that we might need to do is we need to have a movement factor. As I said, we're going to multiply the factor by the final position, which is just the move vector. And we're going to get an offset value. So in other words, we're going to see how far it's currently from the starting position. So we're going to make another serialized field. And actually, to make things simpler, we're just going to bring that down using Alt-Shift. And we're going to call it a float because this is a number. And we're going to have a move factor, right? We're going to multiply it by the vector to get the offset value. Now, there's another thing that I taught you. Since, as I said, we have a range between 0 and 1, we can tell Unity to be within 0 and 1. There is a nitpicky thing here. Like, not a nitpicky thing, but there's kind of a life hack behind this, a trick towards this. We can just type in square brackets before float, range 0, 1. So this is kind of a feature that Unity added for us. You can just put this and it will tell the computer to have a range whenever you put it, whenever you add this component to some game object. Whenever you change the values, it's only going to change within 0 and 1. It has a boundary. It has a boundary in terms of values. So let's go back to Unity and check out whether it worked or not. I believe this is an oscillator script. So let me just, if I, like, as I said, if sometimes, when I accidentally click the obstacles, it's kind of a problem. So what I usually do is I press this finger button so that what happens is I won't ever have to click on these things, right? So I just do that temporarily whenever I'm adding some stuff inside of my game. So let's go to the rocket And let's see whether I've added this or not. I don't think I have. So let's just add an oscillator. You can see that right over here. So we can see that we have a move vector. Now, the move vector is this. It's a vector 3 data type. So we can see like visually like how it looks like. We can manipulate the x, y, z coordinates. Okay, and that is the move vector. Okay, we can't see the start position because it's not serialized, so we can't see that in the inspector panel. But we can also see that the move vector has a scroll bar. And it's because we use the range. The range value helps us keep this float value between 0 and 1. And since it's a float value, it's a decimal value. That means we could access the individual decimal values between 0 and 1. And obviously in 2 decimal places. Okay? And that's really that. I wanted to introduce how vector 3 looks. It's not finalized yet. We need to do more than just, talking about this. So let's go back to our code and see what we can first do. Well, the first thing we need to do in our start method, whenever your game starts, we need to tell the game, we need to tell Unity that what is our start position, that our start position is indeed the position where it currently is. So what we first do is we do starting position, so start position, and not new vector 3. It's just going to be, and think about it, what is that statement that helps us say what's the current position of the object? Well, it's transform that position. Transform position, which is another thing. Well, did I say another thing? Maybe it's like those. Sorry, just forget what I said. Transform dot position is something that you just need to kind of memorize. It should just come out of your head. That transform dot position is just basically saying the current position of the game object. Keep that in mind. Try to connect transform the position and current position. Okay, just connect these things together, and you will just keep on remembering it. Okay, and obviously keep on practicing. So that's the first thing we want to do. Okay? And now another thing we want to do is, well, in the update method, because we're going to constantly change the value of offset, well, first of all, we didn't make a variable offset. We can't see that anywhere, so we need to make that first. Well, we need to first think, is offset a float value or is it a vector 3 value? Well, as I said, offset value is the position relative to the original position, where it is right now in the update method. So if it's a position, it's a coordinate. So it's not a float method. It's not an int method. It's a vector 3 method. It's not new position, but we'll call it offset. Okay, so offset is going to be the move vector, as I said, and it's going to be multiplied by the factor, the move factor. Okay, and that's going to be the vector 3 coordinate. Okay, and what I'm going to do now is I'm going to transform that position, the current position it's set, where it's at, right? Current position, transform that position. It's going to equal the offset plus 1. So then we could find the value between 0 and 1. So we kind of made, that's saying 0 and 1, from between negative and 1. That's the values we're trying to look at. Okay, so the reason why I did plus 1 is because so that our value is constrained within negative 1 and 1. Because we'll talk more about it. It's about sine graphs, but the real reason why I said plus 1 over here was to be within the negative to positive 1 range. Okay, so let's go back to our game. Let's see whether and did I just decide to put the oscillator on this thing? My goodness. You shouldn't, what did I just do? You should never put the oscillator component in your rocket. Your rocket will just, oh my god, go crazy. Okay, so let's not do it on the rocket. Let's open the obstacle. And I think I've already decided my obstacle to be this. So let's go to this obstacle and add the oscillator, essentially. Okay, so I don't think I added, oops, not that one. I have to add the oscillator component. So you can see that over here. So what I'm going to do is we want to move the vector by some certain amount, right? So we want to move it by, let's say, for now, let's make it 3. So what we're going to try to do, oops, did I just change it? I think I did something wrong. We want to, I entered the box collider. We want to go to the oscillator component, right? And I want to change the y value because what I'm going to do is I'm going to affect the y value. If you want to affect the x value, you need to change these values over here. But I'm just going to keep it 0 for now. But for y value, if we want to play the game, well, first of all, let's check the console errors. Ooh, sorry, I did not mean to. What happened to my brain? Sorry. I meant the start position plus the offset. So when I say the transform.position, the transform.position should be the start position plus offset. I don't know what was wrong with my brain. The reason why we add the offset with the start position and the reason why we make the transform.position, the current position, equal to that is because we're trying to move away relative and with respect, like away from the original location, which was our start position. And note that we have already stored our start position to be our initial, the first position when the game starts. The instant the game starts, the first position is recorded by the start position variable. It's stored by that. So then we could use that again in the transform.position whenever we're trying to manipulate that. So just note that transform.position can be manipulated. Although it's not a variable, you can still manipulate this. And we're going to add the offset, right, with the start position. So we have an offset value, which is the current place where it is with the move factor. So it's moving away from something. And we're going to add that with the start position. So it moves relative to the transform.position, right? And another reason why we have to do this is because we cannot add a vector 3 value with an integer, right? Vectors can only add with vectors. That's the thing you need to know in Unity. Okay, so let's go back to our game. I think that problem should go away. It did, so that's good. So let's see the thing again. So is this the oscillator? So yes, if I play the game now, and I go to the game, you can see that it's not moving at all. So we need to actually change our move vector to y. Like let's say we need to move it to, we need to move it to 3, okay? And if we change the move factor, it's going to go up 3. Now, if I change the x to, like, let's say 17, and I now start scrolling the move factor, it's going to start moving from beginning to the end once I start scrolling these things, right? That's what I'm trying to talk about. So the move factor is just telling me, like, once I start scrolling it, I'm going to multiply this by the move vector to get our offset. And then we're going to add that offset with our starting position. So it's going to move relative to the starting position itself. So the result isn't, and a lot of people get this wrong, just because I'm scrolling it, the move factor isn't the change that's happening. It's the current position, okay? So keep that in mind. The current position is changing, not the move factor. Obviously, I'm tweaking the move factor, but the result you're seeing right now isn't the move factor. It's the current position, okay? And you should just keep that in mind. So if I, again, make this 0, treat move vector, again, as the final position. So that's actually a good thing to keep in mind. So I'm going to, first of all, once you stop playing the game, as you know, everything gets reset. So I'm going to put this as 3. But another thing that helped me keep in mind was I didn't know very intuitively what move vector was. So we can make use of what we learned today by using tooltips. So a tooltip, and we can just call this the final position. And offset can be the offset from initial position. Okay, so these two things are going to help us understand a bit more, especially when you're going to go back to the code. You might not know, hey, what's offset? And then you can see the comment. It said, oh, okay, so it's the offset from the initial position. Okay, and if you go back to our code, like into our Unity editor, you can see that, hey, I don't know what move vector is. So if I go down and I hover over it, you can see that, oh, it's telling me the final position. Okay, so that's just one way we could make use of that. But one thing we found out was that we have to manipulate this physically in order to make this thing move. Now, what if we just want to make it move automatically, just like the thing we did for the spinners? Well, that's why we have to talk a bit about signs, okay? So before we talk about some specific thing called Mathf.Sin, we need to understand what sign really is. Now, if you already know what sign is, you feel free to skip this part of the video. I'll attach a timestamp so you could just skip this part. But we need to understand what sign is, okay? So think of this as a circle. Let's wait for the circle to come back over here, okay? So we have a circle, and there's a point, and it's moving around the circle, okay? And then it goes again, okay? So that one circle is called a period. For us, it's called a period because, in other words, that one circle was one oscillation. Because this point is moving many times around the circle, but that the time it took, like the time it took for that point to move around to move on the amount of time it took for the point to move around that circle only once, we call that a period. Now, if we were going to make this a graph, it looks like this. So we started from here, and it went here, and it goes down, and it comes here again. So then we start repeating again. So we call this entire one thing, a cycle, okay? We call that one cycle. And one cycle, in other words, we just call it one oscillation, okay? Just put these two things together. So you can see that from picture, we can see that the point is moving around a circle, right? But if you see that through a graph, right, we can see that it starts from 0, then it goes up 1, then it goes down 1, then it goes to 0 again, right? So then this one entire thing is one oscillation, one cycle for this point to complete one movement of a circle, okay? And then we can see that it went from 0 to 2 pi. But to think of it more deeply, we can see that a circle has 360 degrees. To understand the geometry of it, a circle really has 360 degrees if you think about it entirely, right? That's why you can say, oh, 360 no scope. It's because you're moving around as a circle, you're rotating around as a circle, and then doing a sniper shot. So that's where it doesn't derive from there, but that's one application of the use of using 360 degrees. So just keep in mind that 360 degrees as a whole makes up a circle. Now, we have another thing, we call it radians, okay? So we can say that 360 degrees equals to 2 pi radians. I didn't put this here properly. And we can see that 2 pi equals to 1 period. So 1 period gives us 2 pi distance, okay? That's the distance of how long it is. But in angular terms, that would be 360 degrees. Now, you might be asking me, what in the world is radians and what in the world are? Well, you know what angles are. Angles are like the angles in the circle, right? This entire thing inside is an angle. But you might not know what radians are. So we're going to introduce ourselves into radians, okay? So the reason why we use radians is because we need to convert the angle to radians, as we cannot multiply the value just by the angle of its angle itself. So we have a thing called SI unit. Think of just a simple equation like force equals mass times acceleration, okay? F equals ma. In order to satisfy that equation, we need to follow a thing called SI unit, okay? So a mass has an SI unit of kilograms, and an acceleration has an SI unit of meters per second squared. So in order to satisfy the equation, we need to multiply kilograms by meters per second squared, which gives us kilograms times meters per second squared. In other words, newtons. That is the force. So in other words, we cannot use grams times meters per second squared, could we? So we need to divide that. We need to convert grams to kilograms so that we can make it kilograms times meters per second squared. So similarly here, we cannot use angles. We cannot use angles to multiply by real term values. So like we cannot multiply by distance. We cannot multiply a distance or some sort of distance really related thing, because we're going to talk about distance here, or length by a degree. We need to convert it to radians, because radians is the SI unit of angles. Okay, radians, in other words, is just like a length. Okay, radians is just basically a length of the angle. Okay, and the reason and because of that, we need to convert it. So physically, how we do it is we get the angle and we multiply by pi over 180 to get the radian. And to get the angle, we do it the other way. So we multiply the radians by 180 over pi. So that's just a simple formula. But you might be asking me why you might be doing this. So if you go back over here, there's a, oops, I don't know what I did, why I did that for. So we have a thing called Mathf class in Unity, okay? The Mathf class, as I said, made by Unity, is, if you think of it, if you ever used Java, it's called java.math, right? It's similar to that. Mathf is similar to java.math. Mathf is just a class that Unity made, which consists of many different mathematical kind of methods. They made it for us, even constants like pi. You can see that over here, like 3.1415926. So usually what we do is we make our own variable, pi, make it a constant, and we make that equal to 3.1415926. The problem with that is that we made a limit. We have a limited amount of decimal values. Now we know that pi is an irrational number, but Unity made a constant that's a bit more better than ours. It stored a very longer decimal value than ours, so it gives us a bit more of an accurate value if you think about it, right? It also has trigonometric methods like sine, cosine, tangent, and because of that, we're actually going to be using sine. Okay, we're going to be using sine for our thing today, and we're going to know why a bit later. We also have things like powers and square roots. We have interpolation. If you don't know what interpolation means, it's just another word for saying calculating some values that are between 2 points. Then we also have limiting, repeating values, so like min, max, giving some boundaries, right? And then we have also logarithms, and we have actually much more. You could also refer to the Unity manual, Mathf. You could check it out on Unity documentation. And you can also click on this math script reference. It's going to give you an entire layout of what they have, what they don't have. These things in pink, it's just like the different methods that this class offers. And one reason why Mathf is a bit better than Java.math, it's just because you don't have to refer to it. You don't have to like import it on top, like using Unity engine stuff. You don't have to say using Mathf, you know? Like we don't need to do that. It's already automatic. It's within this Unity engine class, if I'm not wrong, or maybe in the system.collections. It's within one of those 3 classes, and that's really good because then you don't have to waste your time like writing, hey, using blah 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 math and stuff. That's the reason why I personally like Mathf. Okay, so that comes about our own topic, which is the word tau. Okay, so let's actually play this. Let's actually try to understand what is this. So as you see from this example here, we have like some sort of line, right? And it makes a circle. So we can see this red line as our radius of the circle, right? But now if we make that vertical, right? Make it vertical, stand out, and curve it to the circle, we get a length of 1 radian, right? So this red thing is 1 radian. Now, if we keep on stacking them around the circle, we can see that once it reaches, 180 degrees, we get pi radians, which is 3.141596. But if we start stacking them even more, right, we're going to get 2 pi radians, which is, in other words, tau, 6.28. So tau is another constant that I'm going to introduce you today. So if you're not familiar with that, congratulations, you learned something new. Tau is just basically like the pi without one leg. And tau just basically means 2 pi. So 2 times 3.141596, which gives us around 6.28. And the reason why we need to talk about this is because we're going to use this thing called sine. Okay, so in our code, we cannot just use angles to multiply by length. As I said, because radians is the SI unit for angles. So we need to multiply everything by radians. Okay, so let me just check if I did it or not right. All right, so let's go back to our code and try to figure out what to do. So first of all, as I said, we have a thing called cycles, right? We have 1 period, which is 1 oscillation. We want to know how many cycles it can do from a given time period, right? So the first thing we can do is we can make the serialized field happen, right? So we have serialized field, and we can call this some sort of float, and this is the period. Period is like how much time it takes to complete 1 oscillation, 1 complete circle, right? So we can make this initialize as 2f. We need to add an f because this is a float, right? This is a float variable, so we must have an f on it. Yeah, and then this is serialized because we can always manipulate the variables from there accordingly, okay? And then what we can also do is we don't need to... Actually, we'll just keep it there. I'll tell you why in a second. But we can also make another thing called cycles. So it'll have a float data type because we're going to divide it by a period, which has 2f, right? So we're gonna have to figure out how many cycles can it do given its period. So how can we do that? So the way we calculate cycles is by dividing the amount of time, the duration, over the period itself. So the way we find the time it took for something in Unity project, it's by using time.time. Time.time is just referring to the amount of time it takes. In other words, the duration. If you kind of think about it, it's just like a duration. So we divide that by the period, and that's going to give us the cycles. Okay? And we're going to create a constant. The way we create a constant is const, const. And it's going to have a float data type, and we're going to call this a tau. T-A-U. Remember, tau is just basically 2 pi. In other words, just 2 multiplied by the pi constant. So in other words, we could just say 3.1415926, but obviously that's very long. Or you could also just make a variable pi. But as I said, we could use the Mathf class. So we can use Mathf.pi. Mathf.pi is just going to refer to the pi constant that the Mathf class already made. Okay, and we're going to multiply that by 2 because 2 pi equals to tau. All right, and we got ourselves a constant, tau. Congrats to you. And then another thing we're going to do is we're going to make another thing called a float raw sine wave. Okay? And what this thing will do, it's just basically going to find the angle using sine. In other words, we're going to say sine times cycles of tau. All right, so let's actually write this out completely so that you can kind of get a rough idea of what's going on. Cycles times tau. All right, tau is the constant that we made, so we made a variable called tau, and then we're gonna multiply this by some sort of movement factor, right? So we had the move factor. The move factor will then equal raw sine wave, and we're gonna add this by 1f because we want to have it between -1 and 1. But we're also going to divide it by 2 so that it could be within 0 and 1, not within -1 and 1, right? Because we saw that the move factor itself was between 0 and 1, if you thought about that, right? So just keep that in mind. And then we're going to have the offset, as I said over here, and we had to transform the position. So if you think about it, over here, the move factor was between 0 and 1. And that's why we divided by 2, because if we didn't, the value was going to be between -1 and 1. So that's the reason why we did that. So let's see. They're saying that cycles does not exist in the current constant. It's because it's because I didn't call this cycle, so I can just change that to cycles, and that should do the job for us. So let's go back and check out whether our job has been done. So if we go back here to our project and we go to our oscillator, we type y equals 3, our period is 2, and we play the game now, we can see that the thing is oscillating. So congrats to us, the thing is oscillating itself. We can see the variable itself by, it's oscillating from 0 to 1 by some decimal values. Now, if we decrease the period, it's going to go a bit faster. It goes super fast if you see it. Or if you increase the period, it's going to start getting slower. All right? So the reason, if we go back to the code, the reason we multiplied cycles by tau is because we want to know tau is just going to give us a constant, right? And cycles is going to give us the amount of cycles we have. So we're going to multiply that by 2 pi. Right? 2 pi gives us 1 circle. Cycle is just 1 circle itself. So if you multiply the number of cycles we have by the amount of radians for one circle, we're going to get the amount of radians for 5 circles. And we're going to find the sine value of that. And we're going to get, basically, in other words, move factor, the value move factor itself. Okay, so we kind of found a way to simplify our task even more, right? Rather than just having this offset value up there. So instead of manually manipulating it from our code to change the value, we have found a way for us to automatically make the object move itself by code. Okay, so we don't have to tweak with the scroll bar to make that thing move. It can just move by itself thanks to our code because we're using Mathf.Sin. All right, so if you're ever wondering why we use sine, it's because we're trying to find the move factor. We're trying to find that decimal value, which we're going to multiply by the move vector, the final position, which gives us the offset. And we're going to add that relative to our start position, so we can make that equal to the current position. So it starts moving and starts oscillating. Okay? And we divide it by 2 so that it's within the 0 and 1 category. Okay? Now, there's another problem. If you kind of think about it, there is one problem to this code that I haven't told you yet. Now, what if we set this period to 0? It stopped. We have an error, right? We have an error that's saying that please input the value for position. It's not valid. So input position is NaN, NaN, NaN. So that brings about another thing to talk about. So, but again, if we don't put 0, the thing is normal. So let's figure out why is that the case. So if we go back to our thing, and obviously there's nothing else to talk about right now. Let's go back to our code. The thing is, let's think about why it stopped when the period was 0. Well, it's because mathematically, period is the denominator, right? So cycles, the time is being divided by the period, and anything divided by 0 is it's not right. It's impossible. So I can prove you with a calculator right over here. So let me just show you something. So if I divide 8 over 0, we're going to say cannot divide by 0. So this is a scientific proof and a mathematical proof that you just cannot divide anything by 0. You can even ask Siri why you cannot divide by 0. You can also ask your home assistant why you cannot divide by 0. Just ask any computer software. You just can't divide by 0. So what can we do to make sure that it will not have this problem whenever you divide by 0? So in other words, how do we tell the program that whenever our period is equal to 0, we just don't make these things run? Well, if you remember from the last class or last few classes, 2 classes ago, we made a condition, right? So if the period is equal to 0f, we need to type f because it's a float. We can just put this in the brackets in the one line. We're just going to type return. What return does is just, just return this program and just don't run anything else. Done. Just return from here. Boom, you're done with this update method as long as this is 0. Right? But there's another problem in this code, okay? So let's actually go back to our float and let's actually show this slideshow. We can see that 2 floats can vary by a tiny amount, right? So if you have a float like at 0.00, it could also be 0.001, right? So just comparing by, 2 decimal places with the 3 decimal places, it still means it's not 0, right? So you can say that because it's a decimal value, things can vary, even though if you round it, they're the same thing. And this is why it's really unpredictable to use this equal sign with floats. Right, it's just unpredictable because you don't know. These decimal values are really small. So even if you're going to compare 0.00 with 0.00001, that still means it's not 0. So that's why it's really unpredictable to use some 0f to say that, hey, that's the value, and boom, I'm pretty sure the programs are going to work. But that's where bugs come in. So we need to always specify some sort of acceptable difference. So the smallest float we have in Unity is called Mathf.Epsilon. So this is where we're going to apply the Mathf again in our code. But the smallest thing in Unity, the smallest value we can ever get, is recorded by this Mathf.Epsilon. So we always use this Mathf.Epsilon in our code, anywhere in our code, whenever you're trying to compare with 0. Okay, especially when it's a float. So for instance, the syntax behind this would be like, hey, if period was less than or equal to math.epsilon, then we return it. Okay, so we use less than or equal to because values could still be lower than math.epsilon. So it's just like kind of a safety kind of a scenario where if it was less than that, then we still stop the program. Okay, because there are always bugs in our game. So to avoid these problems, we shouldn't only just do equal, but also values that are also less than mathf.epsilon, because it's not recording all of the zeros there. Okay, so let's go back to our code. And the only tiny change we need to do is just do mathf.epsilon. Okay, and if we go back to our Unity thing and we play it now, if we set the thing to 0, if we play the thing right now, let's play the game. If we play the game right now and we set the period to 0, it's still saying there's a problem. Okay, let's try to figure out why. Oh, it's because we forgot to put less than or equal to. So let's just... If you would like to learn a bit more about mathf.epsilon, you could always check out the Unity documentation. But let's actually play this game for now. And it's doing its thing. So let's go to the period script. And let's just change it to 0. Now you can see that although the thing has stopped, we don't see any error messages, that NAN message. Okay, and that's why I wanted to tell you guys how to, some cool ways to fix this problem, especially when you're trying to figure out for hours, like, what's the real problem? Well, it was because, one, we didn't use we didn't use Mathf.Epsilon, and two, we didn't make that condition that when it was equal to, when it was less than or equal to Mathf.Epsilon, we return it, so it doesn't really run that part of the program. Okay, so that's one thing we done. Now, another thing that I said is this is kind of unnecessary to see if you kind of think about it. So what we could do is instead of making it serialized or anything, we can just make it float, because we're not going to affect or change these variables by any means. So we can just make it float move factor. And if we go back to our game, we shouldn't just see that at all. We should just see a move vector and period. Okay, so that's actually really all on on how to make oscillators in your game. You can go really crazy with it. Okay, so for example, let me just show you like how crazy you can go with this. You can change it by this you can change it to the right by some amount. You can also change to the left by some amount. Oops, sorry, like that. You might not want to go super crazy with it, otherwise some people can't even play the game. You can also make it go front and back, right? You can also go super crazy with it, how you want to do it. You could decrease the period so that it's like that, right? So it gets faster. So again, you should know that the lower the period, the faster it will go. The higher the period, the slower it will go. So just keep that thing in your head, how periods work. The longer the period, the longer it takes for the oscillation to happen. Okay, so that's that. But I'll just keep mine as making our final position 3 and changing our period by 2. Okay, so that's really that. Let's see if there's anything else. Well, let's actually talk about designing level moments. This is something about content-based. This isn't something like what we're going to do right now with our game. But this is something for you, some beneficial things for yourself, how to make your game a bit better. Okay, so some cool, useful game design approach. One, you can also design your moments. So you need to design your moments somehow. You have that intention to execution process, right? For me, it was a bit of a Mars-like kind of game. So I want to give that kind of moment that you're feeling as if you're on Mars. So you need to have some sort of rocky obstacles, some dangerous obstacles, because obviously Mars isn't safe yet, right? It's not habitable. Well, in the future it will be, but right now it isn't. And I'm trying to make the game as if it was right now, not in the future. So you could also make scenarios where you need to fly under some obstacles, you need to maybe fly over some obstacles, or perhaps there's a gap and you need to fly through it. So it's really like tense. It's a tense situation, and you need to also time your flight. So you could create some timer that if you didn't reach to some certain place in time, it's just gonna explode. So you could create these conditions. You could also land on a moving platform, so the platform itself can oscillate. You can put that oscillator script on the goal cube and make that thing oscillate. You could also make me fly through some narrow tunnel. These are just some examples. You could also for our game, for example, some things you could do is like you could make the rocket slower if it gets damaged, so you could have some health bar, and every time you decrease the health, it really slows down your rocket speed. And then it maybe fastens your rocket, like it increases the speed whenever you get some booster. Like there's some boosters in the air, you need to collect them. Once you touch that collecting object, then once you get it, you can make the speed of the rocket much faster. You could also make the level really dark and you could add light onto the thing. As I said, I use a spotlight and I activate it. I toggled it using conditions via code. You can make the level dark and give some suspense scenario based on how you want your game to be. Try to give it some story. Try to give it some challenge to it. Try to make the player feel like they're challenging themselves to do something really hard. Not like forcing them to get challenged, but like really naturally they're challenging themselves. They want to make themselves get to that end point of the game, right? So try to do that. Try to do that with the game. You also maybe want to make a closer camera so that you can't see everything. So really, in the end, it's a bit suspenseful. You don't know like what's everything in the game unless you play the game several times. So that's another case. You could also have a bigger rocket, maybe it's carrying something. Like let's say it's like trying to carry some It's trying to carry some cargo or some boxes which needs to be secured. So if these boxes maybe get touched, it's going to affect your entire gameplay. You're going to get hurt. You're going to lose points or something. You could also have reverse controls. So some games do this. You can reverse your controls. So if you're going to press D, it's going to turn left. If you're going to press the A key, you're going to turn right. That's the same thing appropriately for your left and right keys, right? So you could make your game really challenging, and maybe so on. The ideas are endless, but these are just some examples that you can do for your own game jam project, right? Your final game project, because there are some things that I'm asking for you that you need to do for yourself. Try to add something that I've not taught you. You know, try to go over the internet, try to use your ideas and try to implement it in Unity using your own knowledge or the things that you have so far with Unity. If you're still confused, you can go on over a call. You can go on over a call with me, or basically any other members on GDC, and they can help you out, right? Try to get help, because it's very clear that we cannot do things ourselves, right? We cannot always do everything ourselves. We need to get inspired from the external world to be able to make our things happen. Okay, so that's my thing on that. Finally, let's talk about quitting an application, okay? I already talked about this, but as I said, I want to create some sort of timestamp, some evident timestamp that, hey, if you're ever confused, you can always refer to this video and just come back later, maybe in the future. And if you forgot how to quit your application or how to add that code, that segment of code, you can always come back here and figure it out. So how do we do it? So we need to have a goal where if you press, like, let's say an escape button, that's usually the go-to button whenever you want to quit your games in Unity, or basically any games in general. So we need to create a script, right? Because we do have that thinking again. You don't have currently any script that has meaning to do with quitting your application. So you need to create your own, another whole new script, which is intended for quitting applications, right? So then we could create some logic inside of that code using application.quit method. So this is the statement that we need to run with the given condition. So the condition is basically that if we press the escape button on our keyboard, and once we press it, we're going to quit the application. And we also need to add a debug line to make sure that, you know, the thing that we did worked. Because in Unity, when we press the escape button, especially when we're using Unity Editor, when we have not built our game, then we need to have some sort of debug message popping up, because Unity Editor doesn't quit the game. It doesn't, because you're play testing it. It's in a Unity Editor app. So you just need to keep that in your head, keep that in your mind, that whenever you're gonna try quitting games on Unity Editor, that won't happen. So you need to have some sort of debug message to let the code tell you that this is actually happening, okay, in the background. So how do we do that? Let's try implementing that in our code. I've already made a quit app.cs. You can already create your own script through by going through the scripts folder, right-clicking, create a C# script. Open that C# file, and you should see something like this. All right, and we should already say that we're not going to be using the start method at all, right? We're going to be using the update method, because it's going to update every frame to see whether we're going to call that certain key or not, right? The escape key. So we need to think, okay, we have a condition, right? But what's the condition? So we first start off with an if statement, because that's a conditional thing to start with. And the if statement within that will be input, right? Input.get key down, because get key down is like whenever you press the thing, and that's when it starts. So when you press from the bottom, then we run the code. Then we got to do key code.escape, right? So it's the escape key word is just capital E escape, right? So what we do here is we first need to say we call this specific statement. It's just that same thing. It's just like memorization. If you want to quit an application, just remember application.quit, capital A, capital Q, and with parentheses. Okay, so try to connect these things together. Application.quit, quit game. Application.quit, quit game. All right, both of them have capital A and Q. Okay, and we need to think about it. Do we want to message the user after the application has been quit or before the application has been quit? Well, we need to actually message before the application has been quit. Okay. Dog sudo debug.log, and we say we quit the game. So application, we quit the game, right? We can just say something like that. We quit the game. we need to put this before, because when you're quitting the application, you're just quitting it. Okay, so we need to send that message before we quit it. By sending a message and then quitting the app. Okay, so whenever you're trying to do something that's such as quitting the game, or you're trying to run a method, if you want to tell the user that this has been done, you need to tell it before it runs the method. Otherwise, it's going to run the method, then tell it, it's just going to usually take some time with getting that response. So let's go back to our code and let's see whether change has been made. So let's go to the console, let's clear it, let's try playing the game and see whether it has worked or not. So if I press space bar and then I press the escape key, oh, it's because I'm so dumb. Okay, so we need to, it wasn't coming up because we forgot to add the script inside of our rocket component. Okay, yeah, it can be in like any game object. Okay, it doesn't have to be on the rocket. You could just create an empty game object and add the component there. That's usually the best way to go. So let's just go here and press the escape button, and you can say that we have quit the game. Okay, so whenever you have built the game and really played it and you press the escape button, your game should quit. Okay, so that's something that you must have in your final game project, and basically in any games. Okay, you should have, maybe in the future we'll learn about buttons and UIs. You can have some button that says quit game, but usually you should also try to have an escape button so that if someone wants to just automatically leave the game, like let's say he was like working or something and then his mom or his dad came or his boss came or the teacher came, they want a quick button to. I'm not trying to encourage this. I'm just saying that for their safety, you could let them have some quick buttons so that when they press the escape button, they can instantly leave the game and go. Again, I'm not encouraging you guys to do this at all by any means. I'm not at all. So that's that. Okay. So yeah, that's really it for today's meeting. This was a really, really, really long meeting. I apologize, but this is because it's the final game project meeting. Okay. Well, not the final game project. This is the second game project, but it's the final video for this certain project. So there were a lot of things that I had to go through and really teach you guys on what to do where. But hopefully you guys know what to do, right? So I have added already all announcements, what you have to do on your Discord announcements page, like any updates that I gave. Assignments are going to come out soon, so just be sure to look out for that to our next XP. Yeah, so just that's really that for this video. So thank you very much for watching. I hope you've learned something, and I'll see you on March 19th. Peace. Well, first, before I say peace, stay creative. Peace.